Hello students, welcome to fifth video of assignment 7.2. In first video session we had second order differential equation of charge for series LCR AC circuit. In second video we did derive expression for complex current for the same circuit, and in last two videos we had separately discussed what if we have only R and L connected with AC source or R and C. Okay, in this video we have LC combination. Question is, write expression for complex current for AC circuit with series combination of capacitor and inductor. Also draw graph of current versus time and voltage versus time. So just like previous case, before moving further, going ahead, let us recall expression for voltage, current and impedance. So complex voltage can be written as V is equal to Vm e raised to j omega t. This is exponential form of voltage. You can write it as Vm cos omega t plus j Vm sin omega t. So first term is real part of voltage, second term is imaginary part of voltage, and so we will not be using this to plot graph of voltage. Similarly, current can also be written as I is equal to Im. What was the equation of current? It was e raised to j omega t minus delta. See, there is phase difference between voltage and current. What is delta? Delta is the phase. Who determines delta? Impedance. So what we need to remember here is what is Im. Im is maximum voltage Vm by mod Z. What is Z? For series LCR AC circuit, Z can be written as R plus J omega L minus 1 by omega C. Now if you don't have C, don't use last term. If you don't have L, don't use middle term. If you don't have resistor, don't use first term. Okay. So this is Z. Now the circuit which we are talking about right now is the series combination of L and C. So if I have inductor connected with capacitor in series, and then if this combination is connected with alternating source, it becomes LC circuit. So how much is the impedance for this circuit? I can say that Z here is, see, there is no R. Look at this. We don't have any R. So for this circuit, I can write Z as simply J omega L minus 1 by omega C. There is no real part. And then if I have to plot this, how do I plot it? So I'll have to make one assumption. I can assume that omega L is greater than 1 by omega C, and if this condition is satisfied, this bracket will have positive value. Okay, so with this assumption I am putting it here. This is omega L minus 1 by omega C, and there is no real part, so there is nothing to be represented on real axis. Okay, it is purely imaginary, and then I can say that this itself is my mod Z, and then this is my delta. So how much is delta? Delta is 90. How much is mod Z? So mod Z is omega L minus 1 by omega C. You can also write this as XL minus XC. Okay, and 10 of delta is 90 degree, or else pi by 2. So what is the equation of voltage? Voltage is Vm cos omega t. What is current? Current is, if I consider the real part of this current, it is Im cos omega t minus delta. So it will be Im cos omega t minus delta, which is 90 degree. I'm sorry, I made one mistake here. Delta is 90, not 10 of delta is 90. Delta is 90. So if you have omega t minus 90, it becomes function of sine, and then current is Im sine omega t. Okay, so I is Im sine omega t. And now look at the equation of voltage, look at equation of current. One is function of cos, other one is function of sine, but variation in both is determined by same term omega t. So how do we represent it? Let us first try to plot voltage. So if I take time on horizontal axis, voltage is function of cos, so I can show variation in voltage like this. Now current is to be shown as function of sine. It is Im sine omega t. And then what I have to do here is I'll have to take sinusoidal wave. When you are plotting this graph, you have to be careful about certain things. First, this peak value. This peak value must be same on both sides. Okay, this Im should be same on both sides. Secondly, one is function of sine, other one is function of cos. So make sure here I have made slight mistake. Exactly when voltage is 0, current should reach maximum value. See, my mistake is there is slight mismatch here. Okay, this current peak, let me redraw it. If we take voltage graph like this, I have to make sure that exactly when voltage is 0, current reaches peak value, exactly when voltage is maximum, current becomes 0, and so on. Okay, so if I am starting current graph from here, it must reach peak exactly at this time. Okay, and that should be followed for rest of the graph. And I should also be careful about the peak value on either side. Okay, it should be same, though not apparent here. So this is the current, variation in current, and this is the voltage. So this is the graph of current versus time and voltage versus time for LCR, L and C circuit, LC circuit. Now you can find out what if this assumption is wrong. What if I consider omega L to be less than 1 by omega C? How things will change? Ponder over it and try to find out equation of current and try to plot that equation of current. Okay, I leave it to you. That is all for now. Thank you.